To complete this next section of the Gizmo, we're going to collect some data from stars. So I'm going to start in region A, and I'm going to select one of the Cepheid stars here. And you can see they're the two that have their brightness changing over time. They get brighter and dimmer. Once I've selected a star, I'll click Collect Data, and you'll see it starts to graph the apparent brightness of that star over time. That's how bright it looks to us from Earth, whether we're looking at it with our eye or with special instruments. So what we need to look for is two different values. The first one is easy to collect. It's just the mean brightness, or how bright that star is on average. So that'll be about the equilibrium position for the wave, but I can just click Show Mean Brightness for this star. So this is star A171, and its mean brightness, which means average brightness, is 2,499 suns. Now, I also need to find its period, which is how long it takes for this pattern or this wavelength to happen. So when I click time probes, I'm going to get two probes, and I can put them at different places on this graph. So I'm going to put this time probe at 0 on this graph, and I'm going to put the other time probe at the next time it reaches that mean brightness, so at equilibrium. So I can see now the difference between 4 and 0 is 4.1 days, which tells me there's a period of 4.1 days for this graph. Once I know the period, I'll use the data corrected by Henrietta Lavatte to understand the mean luminosity, which is the average absolute brightness of that star. I'll do that by clicking the Distance tab, and I'll see a graph here that compares the period to the mean luminosity of those suns. And this is data that comes from stars that we know their distance using parallax, but we're going to use it on stars that are too far away to use parallax. So if I find it, I can turn on the Show the Draggable Point, and I'm looking for a period of 4.1 days, and the x-axis is the period. So I'll drag that dot to 4.1 days, and then it's going to tell me the mean luminosity. So the average brightness of this star is 1,560 suns. 1,560. So looking at just the data, we've used the period to find both the mean brightness, which is the average of how bright it looks in the sky, and the mean luminosity, which is how much light the star is actually making. So the mean luminosity is how much that is giving off, and the mean brightness is how much is making it to our eyes. Brightness can also be apparent brightness, which is how bright it looks, and mean luminosity can also be called absolute brightness,